Hey guys, Jason here with the Huntress CTF challenges once more. I want to do a quick video on one of the ones that came out as a medium difficulty. I know we're kind of behind on some of the videos due to other stuff going on, and we do have a couple here for the team that have not been solved, but they're currently being solved. But one of the ones that I wanted to talk about specifically is, let me scroll down to it, Rock Paper Psychic. So this is a medium level difficulty, and it involves downloading a binary file. So it does tell us that we have to watch out for Windows Defender having some problems. I went ahead and already kind of played around with this challenge. I found the flag. I was able to submit it. Works pretty well. And we're going to go into kind of like malware analysis a little bit. It's not surprising to me that we're going to have to really dig into the binary itself and try to figure out what it's doing and try to trick it. But without further ado, let me go ahead and bring up our downloads folder here real quick. So that way you guys can see what we have here. And let me bring you back up here. So if you take a look at the screen, I believe you can see on the screen, yeah. So I have Rock Paper Psychic downloaded. So I have a couple copies of this because I've been playing around with it. And we're going to go ahead and launch the one that actually works originally, which is this copy one that I have here. So let's go ahead and double click on it. And I'll bring it over here. And it says, hey, I'm Patch. I'm a telepathic computer program, right? It's not telepathic. All it's doing is probably recording our choice and then comparing our choice to tell the computer to choose a choice that's actually going to work. So it's probably something inside the program itself that's checking to which option we have and it's selecting the option that's going to beat it to automatically win. Without further ado, let's take a look at this. So I'm going to choose rock. So it says it's made his choice, rock, paper, scissors, shoot. And because I chose rock, it chose paper, so it wins, right? So we can go ahead and try winning again. I'm going to say, okay, well, let's try paper. It's going to choose scissors at this point. So let's take a look at this. And choosing scissors. Okay, so we're not going to be able to win. I mean, we can go to, scissors as well. Let's see, scissors. Oh, I accidentally did that. We'll talk about that, why that happened here. So it's going to ask me to add another choice here. So I made scissors. And what we're trying to get is something like, there's rotating messages here. So it's going to say, I can do this all day. It's going to say, I'm telepathic. What's so hard to understand? I can read minds, right? It's obviously not reading minds. So there's a couple things we could try to do with binary executions. There's multiple ways to trick it, to kind of break it. And the most basic way you could try to do here is you could do what's called like a buffer overflow. And the most simplistic buffer overflow just includes just having a random amount of characters. So let me bring this up real quick. We'll bring up a new document here. And what I'm going to do is I'm just making a bunch of A's, right? So got, 94 A's here. Let's do a whole bunch of these. We're going to go down to 3,000 lines here, or sorry, 3,000 characters. So I have 3,000 characters here, right? If we go back and see this, there are two inputs here. So we could try to utilize this on this one. I'm pretty sure this one only accepts yes or no. So if it's anything other than yes, it's probably going to break. So let's go ahead and do yes and a space and see if that accepts it. It doesn't. So it has to be yes. So let's try that again. And we're just going to go over a few tricks of this because unfortunately there could be a possibility to do a buffer overflow on this. I have not found it. I'm probably not that experienced on it. I did find the flag a different way, which is disassembly of the binary executable itself. And we'll go over that here after this. And so we're going to go ahead and choose rock. It's going to win because it's going to choose paper. And bam. Right? So here we are back at the yes, no. So I could say yes in capital. I'm not sure if it's going to sanitize that or be able to recognize that. It does. Okay, so now it's asking us for another choice. So let's try to overflow this buffer, right? There's got to be a limitation on this, right? So let's copy all the 3,000 characters of my A's, right, and paste them in here, right? All right, cool. So one of the things you should also notice, though, is that there is a limitation of characters here. So if I keep saying, you see it stops right there? That is the limitation. And we could probably figure out exactly what the limitation is here. So let's copy that over to here, and let's see how many characters that is. Looks like it's 2046, which is interesting. It's not 2056 because 1 MB is roughly, or even 1 KB is 1028. So the next step up should be 2056. So it's just 10 shy of either 2 bytes or 2 KB. I think it's 2 KB at this point. My binary math and my programming math is a little rusty on this, but so anyways, it only accepts 2046 characters total. It doesn't allow you to add any more, so we're kind of stuck with this. So let's go ahead and say, let's see what happens if we hit enter here. It seems to be able to sanitize itself and not allow you to overflow the inputs. We could try to say rock, 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 right? Technically rock's in there, but it's still not able to verify. So it's vetting your inputs. It's either rock, paper, or scissors. There could be other words we could try to guess, but it's going to be a long time of guessing, right? So let's go ahead and just open this up real quick in my Notepad++, because that's my favorite thing to look at. All right, and bring this back up. All right, so first things first that we see here is that we see this little MZ, and we'll get to that here in a second, but we also see this program cannot be run in DOS mode. Typically, this is a good indicator that it is a executable designed for Windows environments. Most programs that have to run in Windows usually have to have this line. I don't 100% understand the history behind that. I'm aware of it. If I wanted to, I could probably do some research and create a video as to why that is. But that is an indicator that we look for when it comes to looking at executables designed for Windows, is that they're probably going to have this line somewhere. So let's continue on here. And we see that it's a bunch of data. There's a lot of lines here. Let's scroll all the way to the bottom. And we have, ooh, there's a lot of interesting information. There's all this TM information. These might be the strings. So if we utilize the program strings to take a look at this, that might what show up here on this line. But I'm curious. There's even a printf. So I suspect this is programmed in C or C++. But let's take a look at this. Let's try. I'm trying to see if one of my options is in human readable format. So let's search for rock, and we come here to the middle, kind of the middle portion here, and there's a bunch of human readable format here. So we have some random string here, we have some random string here, but we do have press enter to quit. Interestingly enough, we haven't received that yet. We do have all this information that feeds to us. Do you want to play again with a question mark? Yes, no. And I see that there's these @ symbols next to them as well. Okay, so we could try to do this. We could be like, there's the flag here somewhere. And we need to a flag. It's going to come up with some information required in the program, such as loader flags. We could try to do flag with a brackety colon here, and it's not going to find it, right? So it's most likely somewhere in the file that is not human readable, and it doesn't make it human readable until we win the game. So let's go back here. Invalid choice. So we see the invalid choice here. Let's see. Scissors, paper, rock, ready. I've made my choice. Let's play. These two rock, enter choice here. So here's enter choice, and then there's null characters still to play, right? So we could try to kind of figure out where it's storing this. I don't think we're going to get anywhere with this. We do know that a lot of the output is printing out is human readable. And then something we should also pay attention to is that there is a section here where it's designed to let us win. Somehow it's going to have this output. So this tells me that it is programmed somewhere in this program to feed us winning, but we just got to figure out how. So if there is a possible way to do it without actually disassembling the code, I haven't found it yet. I'm going to show you how I disassembled it. So let's go ahead and close this, because we're not going to be able to do anything at this point. And I guess another thing I was going to point out is that there is an overflow range error. So supposedly you could overflow it haven't figured it out. So let's go ahead and close this out. We're going to close this one out. We're going to just blank this out real quick. We'll minimize this. Okay. So you might be asking, well, how do you do this, right? Let's go ahead and close this out. So how do you analyze a binary file? There's a couple ways to do it. Nowadays, there's things called disassemblers or binary disassemblers. And a really good example that I'll bring up here is GHIDRA. So GHIDRA was designed by the National Security Agency, the NSA, and it is an open source platform that's been released for everybody to use. Now, normally you'll probably see a lot of people, they'll utilize Linux variant distro to kind of do disassembly, which is fine. That works perfectly fine. But GHIDRA is also designed to work on Windows. The two things that you do need to have, though, is that you need to have JDK 17. But if you click on this link, it takes you to Adoptium, which is different from Java. So I don't want to go too much into it right now, but this is probably your preferred method to download a Java development kit. And GHIDRA needs it in order to actually analyze the files. Other things we could look into, like we can look into GDB, which is kind of embedded in Linux. So you could use GDB to disassemble a lot of programs here, but it requires a very intensive and hands-on understanding of the program itself. There's a lot of things you can do with it. You can make breakpoints, which basically stops the code at certain points to try to analyze memory. It's a lot. It can be a lot if you don't know what you're doing. So you could also do IDA. IDA is a, let's see, IDA disassembler. So we also have IDA. There is IDA Free, there's IDA Pro. IDA Free is more or less roughly the same as IDA Pro. There's just missing features involved. And you can see on the pictures here, like it does a kind of a breakdown of how this, shows the code and hopefully disassembles it. And something you have to understand with disassemblers is that it's not converting it back to source code. Most of the time, what's actually happening with disassemblers is that they're reading the binary file and making presumptuous guesses. And they're accurate, but presumptuous guesses based off the language that you select, and trying to tell you this is probably what it looks like. Because you won't be able to go into the program itself and modify source code. You actually have to modify kind of the binary representation or the hex representation of what that's showing. And I'll show you what all that means later. So anyway, so this I did disassembler as well. There's also I think it's like Calvaire disassembler. I think disassembler. Can't spell today. Let's go here. Calver. I think this is it, maybe. Oh, there's also x64 DBG as well. Kind of does the same thing. So you see, there's a rotating kind of topic on how this works. So, and you don't have to use a disassembler. You can use a debugger. You can use like a hexanator, so to speak. But in this case, we're going to use a disassembler, or at least an all. GHIDRA is kind of technically an all-in-one because you can do a lot with it. And we're going to go ahead and launch this. But going back here to GHIDRA, and we'll go into one more here. When you download the release file, so you click on the release file here, there is one for Windows. So when you click on this, it'll download Windows, and you can run it in Windows. And the way you kind of do that is you have a little batch scripts that will run it. And for the sake of not seeing what's on my desktop, I'm just going to go ahead and run it here. So anytime you run like this bat file, so this bat file is going to call into GHIDRA, and I'll bring this over so that way you guys can see this. I would highly recommend running this as an administrator because it needs access to the JDK library, and if it doesn't have full administrative access, you're going to run into issues. So I'm going to go ahead and run this as administrator. We'll bring this over. Let's see here. All right. So here's GHIDRA, and when it pops up, there's this project overview. So at least it does an overview of all your projects, and it gives you tips. So you can keep them or not. And you can see that I already have a project running called RPS, or Rock Paper Psychic. So I know it's not spelled with an S with Psychic. Doesn't matter. It was kind of a rush on my side to get this going. So there's a couple things here you could do once you get a project rolling. Usually, like, let's say if we want to start a new project, so let's do that real quick. We're gonna say it's non-shared projects. Yeah, we're gonna go ahead and just keep that in my downloads folder for now, and I'm just gonna call it RPS 3. All right, because I already have a different project. Like if I open this up real quick, so I have RPS 1, which is the one that I'll show you here in a second, and then RPS 3. But yeah, so we start a new project, and you have these options, right? You have code browser, you have debugger, emulator, version tracking. Let's just open up code browser because that's the most default that most people will load. So I'm going to go ahead and click on that. It's going to load. This takes a second to load. So you'll see that there's a function graph here. I can close that out. But this is kind of the normal look of what GHIDRA looks like, right? So we have a listing in the middle, we have a decompile on the right, and then we have program trees, symbol tree, data type manager, and then a console on the bottom. I don't want to go too deep into this because it's not really supposed to be an introduction like how to use GHIDRA. I'm just going to show you kind of the steps that I worked out into solving Rock Paper Psychic. So from the get-go, you need to import the binary file. So the first thing you need to do is you need to go here. Now, a lot of people get confused because they'll go to open and they think that they need to open a new project or whatever. We're already in a project. So GHIDRA just has containers. That's what the projects are. They're containers for the work that you're doing. And all we're going to do here, instead of open, we're going to go down here to import file. So let's go ahead and import file. And as you can see, it's already pointed to where I have Rock Paper Psychic saved. We're going to go ahead and just open up this exe. So we select file to import, and then this is very important. So when you import a binary file, it's very important to understand that you have to select the formatting correctly. Now here with .exes, usually there's only like 3 of them. Sometimes you can accidentally select something like ELF, which is a binary executable for mostly Linux systems. So just be careful how you do that. And I do want to bring this back up because we were going back to our downloads folder here, and I want to show you something here, right? And because this is kind of what tripped me up a little bit. So remember I said MZ here. So if we go back, we see that there's 3 formats. There's portable executable, old style DOS executable, and raw binary. So if we go back here and I select, let's do this here real quick, and we do a search for MZ file type. I can't spell. All right. It says the DOS MZ executable format is an executable file format used for exe files in DOS. My mistake is I accidentally forgot my own statement of this, right? This program cannot be run in DOS mode, and then I see MZ. We have to separate those two. So MZ is a file format for DOS, but it says right here, this program cannot be run in DOS mode. I believe this was a trick by the author because I accidentally, instead of doing what I was supposed to do, which is just load it as a normal binary, portable executable, because that's what this is, I selected MZ and it didn't define anything for me. I was kind of stuck in a loop. So just don't do the mistakes I did and just be very wary, pay attention to the type of file you have. More likely, if it says this program cannot be run in DOS mode, it's going to be a PE. So utilize this. You can see the language here. You can change the language if you want. We're just going to keep everything default. So let's go ahead and click OK. So it's analyzing the file, and then it's going to tell you, or at least it loads it. Now it's going to ask you it has not been analyzed. Always hit yes. You want to try to figure out all the different functionalities of what this program does. And I'll explain why here after it's done. So we're going to go ahead and just keep it default. You see the stuff in red, leave it alone. It's not a big deal. So we click on Analyze. So analyze it, and you can see on the bottom, it's like disassembling it. It's trying to figure out what's doing. So real quick, on this page, we can see that there's the processor, so it's x86, address size 64. So this is technically a 64-bit portable executable. And then we see Compiler technically is unknown, but it's most likely GCC. And then we see the location. This is pretty good information to have. And we can also see that for some reason, when it loads it, there's some issues with loading imports. These are important to pay attention to if you have problems with a program, but if the program's running fine without these, which it was beating our butts in rock, paper, scissors, you can just ignore it. So let's go ahead and click OK. And so now we have the program loaded. And from the get-go, a lot of people can get very confused about what we're seeing here. So in the middle, we have a listing. This is what GHIDRA is reading from the portable executable, down to how programs run. Programming is not a one-to-one ratio to machines. If you remember like basic computer science, computers operate on ones and zeros, which realistically is just voltages, the difference between voltages. In the old days, it used to be zeros and ones, or at least voltage 0, voltage 1, or voltage 5, or how much voltage is being fed into it. Nowadays, it's a little bit more complicated than that. Don't want to get too much into it, but the basics of it is that the representation of binary, base 2, no voltage is 0, voltage is 1, and then you have a bunch of those feeding into it, and eventually becomes bytes and all that stuff and calls. And this is technically what this is. This is technically showing you somewhat, not exactly what we call assembly language, but it's basically telling the operating system how to move registers and memory and addressing. We're reading basically the closest you can get to the hardware level of what it's doing, right? But on the right side, you see the decompile, and it tells you, oh, hey, it's main CMD. So it's telling you the best guess on what this is. This is not exactly how it's written. It's just the best guess based off what the decompiler can see. And I don't want to get too deep into this. This is not an intro into GHIDRA and how to read GHIDRA. So just keep that in mind. The middle part is technically what's happening with the program. Like you can see there's things going on. Like you can see like JMP is a jump. Like it's jumping. It's got pointers. It's got keywords. I forgot to get out of that. So there's a lot going on. So let's slow down without losing our minds. There's a couple options you could do. So on the window tab, you could kind of show as many windows as you want, but there's two that are super important, especially when it comes to trying to find a flag in a portable executable that's tricking you in rock, paper, scissors. So if I go here to define tags, and I have it down here, strings, I click on it, and we have a bunch of strings. So let me expand this real quick, right? So we have string representation, we have MZ up here, we have PE, and that's why I think it's a trick. It's because both of them are on here. Usually if it's a PE, the MZ is not going to be there. I might be 100% wrong on that, but from my limited knowledge of breaking down simple binaries, I usually don't see that if it's not supposed to be running DOS mode. And we see there's a bunch of information here, right? What we can do is we can use a filter, right? And just like we did with the Notepad++, we can do rock, right? So I'm going to do rock, and it limits it to these locations. And you see there's a memory location here, and we have string value. If I click on it, it does kind of load where in the binary it's showing that. And we can see here, let's play rock, paper, scissors. So it's got a reference here, and we see that there's a bunch of memory locations here. And if I click on this X reference, and I go back here, it's going to take me to a memory location. So now I'm at a memory location, right? These X references, like I stated, they're references to different calls, right? And it's as best human readable format as possible, trying to tell you how these memory jumps are going and what's being told from the program, right? And we see that there's a main, and this is a different way to do it too. So I found this rock by using the filter for the strings, because there's because it was human readable outside of the binary, even when we analyzed the file itself through Notepad++, that should tell you it's a defined string. Like it's not something that's built in the program, because the program can write strings without strings being defined, if that makes any sense. But most cases, people are going to define the strings for it, just to simplify it, right? So this is a defined string that can help me point back to a program, or at least the reference of a program of what the main function's doing, so to speak, right? And that's what we're trying to get at too, is that we're trying to find where the main functions are and how it works. The other way you can do that is you have different program trees. Now this information here is really just like a kind of a breakdown of how the program is supposed to run. Most of the time, you're going to spend most of your time in like data or text, and it's going to like tell you, and you see in the middle it says function. This is GHIDRA's kind of interpretation of how these functions are. And if you click on something like this, and something to remember about programming is that there are defined functions, like you're going to call functions. Almost 99% of most programming languages out there, including C, which is probably what this is made out of, is going to have defined functions. So if I click on this and I go back to this decompile, it loads what it most likely thinks is the function. And it's going to be correct. Like, obviously, you can probably handle with that. Don't have to worry too much about whether or not the functions are defined correctly. That's a whole different topic. But you can probably say, okay, so this is probably correct. And you don't have to worry too much about what's in here, at least for this program, because you can read on here, invalid parameter handler. You can say, like, this is not important, because it's handling invalid parameters. It's kind of like one of those rabbit hole things you don't want to get into. I wouldn't worry about this, right? So the text can help trying to curate where all the functions are and where all the declarations are. The other way you can also do it is you can do in the symbol tree. The symbol tree is going to try to have a breakdown of all the different imports, exports, and like labeling that's going on in the program. So here, there's a folder called functions, and what we can do here is for every program, there's going to be something called main. There has to be a main. Now, that's not 100% the case, but in this case, it's going to be, and it's good to just search for it. So let's go ahead and do main. And we got a lot of mains going on here, a lot of mains. The one that I'm looking for is probably the most top main that I can find, and there's an export here, so just keep in mind, look for the folders. You could click on this, but you can also highlight it, and it shows main void. So it's not taking any arguments. Let's ignore that one real quick and go to this one right here. This one, when I highlight, it's also void. Let's go to the next one. There's main 62. Let's go ahead and click on this function, right? So it takes us to the location in the program where it is, and then it also loads a possible decompile of what it's doing. All right, so we're in the right section, right? We found the main, right? And we see here that there's declarations of variables here. So we have var1, 2, and 3. We have echo bin safe, and then these TMs. Now, if you remember earlier in the video, I saw those TMs on the bottom of the file when I uploaded it into Notepad++. Let's take a look and see, because when I click on this, it's going to reference to the memory, right? So when I click on this, it says there's an undefined echo bin safe. Okay, what about this one? Echo bin safe. So there's a lot of weird echo bin safes going on, right? Let's see here. But it's doing this call, right? And if I click on this parameter right here, it's going to take me in the memory where it's stored, or in the program where it's stored, right? So I double click on it, and if I look on this, this doesn't say anything, but there's a reference here, right? There's also this right here. So if I click on 2 has an address to 3, so let's click on 3, and look at there in the middle of that, it says hi, I'm Patch. So this seems to be correct. If you remember back how the program is ran, and I'll bring this back up here. So if I double click on this, you see the first line is hi, I'm Patch, the telepathic computer program. So let's close that out. If you look on here, 2 references to an address of 3. 3 is right here, so you don't have to go very far. And we see in the middle, hi, I'm Patch. We found the main function of the program. This is probably where you're going to spend most of your time when it comes to decompiling flag-based programs to try to find a flag. So let's take a look at this. I'm not going to worry about this right now. I'm just going to go down line by line. We see a do. So it's going to do something, right? It's doing something, and then there's while true, and there's a reference here. My guess is that these first 6 variables are what the program is telling you, and then in the do, it's probably asking for your inputs, right? And then once it's done with your input, it's going into here to kind of like play the game. So let's go down here. So we see there's LAB references. These are just references to memory, and we don't have to worry about that. But here we see that this TM20 right here, if I call on this, let's see if I can find it correctly real quick. I believe this one right here is a reference to call and store your declaration of what option you have. So let's take a look here, and we have a variable declared here. So var3 is going to equal whatever this is. So the star reference, I think, is a character reference. I'm not a programmer. I understand C to a certain extent, but I'm not 100% on that. This might be just a call reference. And we see puvar is equal to some long number here, and it's read from STN. So 16 seems to be the call for you to select, right? And there's references back to this main program, right? So 16 is here, and we see that it's going to be fed to puvar1, or puvar1. So puvar1, if it doesn't equal 0, 0, which I think is a null value, it breaks, and then it goes to the next one here. So now it's assigning the reference of where puvar is to puvar3, and we see var3 equals 4. If something equals this memory, it goes to this location. I don't want to get too much details into it. We're just trying to get a high level view of this because I'm not 100%. I'm not an expert in C programming language, but I can kind of follow along that there's if statements here where like if var3 equals 4, if it doesn't equal 5, if var3 equals 8. So this is probably where it's checking to see what type of option that you selected. Because then we go down here and we see that there's something called player wins, right? And there's the reference right here. There's a call to it. What we want to get the flag is to force it to call this. Because we see down here that the only way this gets called in this main program is if the var3, which we were talking about, uvar3, doesn't equal null. So somehow, back here, and we see the determine winner main here too, var3 equals whatever the outcome of this is, which is probably null. Something is happening in the determine winner that's forcing our value to turn null to make the computer win. Because the only way we're going to win is if it goes into this if statement. And now this is where kind of the imagination of how to break a program comes into play, and everybody's different about it. The way I did it, and I'll go back here, is that I see a call here, right? So I'm looking at this. It says there's a call here, and we're going to go back into what the actual breakdown is in the listing. And we see get computer choice. So it's going to call computer choice. It comes back, moves a parameter. There's an LEA, which I forget exactly what it stands for. I think it's like a push what's showing. So basically, because it's a reference to a TM, which I think we mostly determined is mostly strings. And we see a call echo bin safe. We see another call determine winner. So this is where it jumps into a different part of the function, or at least this function is called upon, and then it tests. This right here is where the if statement is. If char does not equal 0, then it jumps. This is technically a jump right here, right? But it's not jumping to this because the test is failing. So you could modify this. What I did instead is I see this call right here. This is calling computer main 11, right? I don't want it to do that. I want it to call player wins, which is right here, right? Now, the way to do this is that we're going to edit in the listing. If you edit in the listing, you need to understand how to do references to like memory addressing and like how to do proper calls, how to do proper moves and jumps. So you got to be very careful. Even if you knew C programming, you have to somehow already know the assembly part language of it to modify the program. So let's go ahead and try this real quick. To modify this inside here, we're going to say patch instruction. And this allows, Roger, yeah, I gotcha. But this allows the assembler to allow you to modify it. And you notice once I modified it, the call is still the same, but now the reference ID is different. It's not human readable format. You have to kind of be very careful on this. Now, luckily, GHIDRA is going to help you out with this a little bit. And you can do, and we see on the right hand side, I see player wins. So I'm going to do player wins. So it's going to help you out. It's going to give you the address. And you click on enter, right? And it's going to give you an option. Normally, it's going to be the first option, right? So that's all I'm going to do is I'm going to hit enter. Bam. So player wins main 10. Now we see on the bottom here, where is it? There should be a player wins main 10. So there's already a input here. And we can click on this, right? Whoops, I didn't mean to do that. Let me go back. Luckily there's a back button. Let's do patch instruction 4169 delta 0. Okay, let's just make sure that's correct. We're going to go back up here. Patch instruction 4169 delta 0. So it's the right one. It's the right call, right? So now we modified it, right? We have modified a call. It's no longer calling at all to computer wins. So I didn't have to worry about the if statement. All I worried about is the fact that the if statement was optional to the program anyways, and we had to somehow convince var3 not to be a null. I didn't want to get too much into that. You can. That's definitely an option. You can definitely try to modify this part of the code. But what I did instead is I told it doesn't matter if the if statement is good or not. It's still going to go to player wins. There is no computer wins at this point. So we're going to go ahead and now save this and export it. So go ahead and save it. And to export it as a portable executable, you got to export it back as a binary file. So go here to O. And we see here the options you have. I'm going to select original file. Output file is going to be this. And I'm going to change this to mod. Right? Click OK. Click OK. Now that should be in my folder now. It's probably in here actually. One second. Did it not export it? That's weird. Let's try this again. Options, yep. Oh, I know. Okay, I know where to put it. It's not supposed to put it there. I had this problem last time. That's right. So we're going to do rock, paper, second mod. And then I'm going to say downloads. Let me go up here real quick and select this one, select this one. Bam. Okay, so now we have it in the right folder. So let's go ahead and click OK. OK, and it should have exported it. And there it is. So now we're going to run it. All right. Everything seems to be the same, right? All right, so I'm going to say rock. So I say rock. It has his choice. It's going to say paper. I chose rock, but I won, right? And that's how you kind of, one of the ways you could beat the program. Because regardless of the fact that it's going to choose it, it's going to go through an instruction check, and it's going to try to null out my choice, it's never going to go to computer wins because I completely removed that call option in the first place here. So it's not even going to call it. The other ways you could do it is that you can go into here to determine main winner. And you can see there's a lot of information on here on how to determine the winner. You know, I went simplistic. I just made sure it didn't call computer wins at all. So again, like I said, there is multiple ways to try to do this. You can, I don't want to use the reference like, it's like, yeah, there's a reference I'm not going to use. It's not YouTube friendly. So there's multiple ways to do this. Let's just leave it at that. So hopefully this was somewhat instructive. hopefully people can kind of understand how we got into this and how to kind of beat this. I wouldn't say that this is a very simplistic way of doing it. There's other ways that different binaries hide flags when it comes to CTFs and stuff. So just keep that in mind. Sometimes it can be easy as the fact that one of the defined strings is going to have flag in it. It really depends on the level of difficulty and how much the author puts work into it to hide the flag. So, but that's one way to do it using GHIDRA. Hopefully you guys had some good instructions on this. Other than that, we'll probably have more videos. I know I have a couple more videos to come out with. Some previous challenges have come out with, so hopefully those come out with later on, hopefully this week. But other than that, I hope you guys have a wonderful day, and I'll see you next time.